This video is produced by Pooja Gade. The experiment I'm going to present is a double displacement reaction between sodium hydroxide and nickel chloride. A double displacement reaction is a type of reaction where part of one reactant is replaced by part of another reactant. Double displacement reactions take the form AB plus CD yields AD plus CB. To perform the experiment, the materials needed are as follows: 250 milliliter beaker, 15 milliliters of 1 molar sodium hydroxide, 6 milliliters of nickel 2 chloride solution. The first thing I do is take 2 beakers from the container shelf and place them on the workbench. To do that, I click on the section labeled Containers that is located under the shelf. A series of containers appear. I click and drag one beaker onto the workbench, then a second. I then label each of the beakers by double-clicking on them, naming the first beaker Beaker 1 and the second one Beaker 2. To fill each beaker with the appropriate volume of reactant, I then click on the section labeled Materials located under the shelf. A series of materials appear, and I select the aqueous solution sodium hydroxide. I click and drag it to rest directly in front of Beaker 1 and let it go. A window opens, which serves to decide the volume of solution with which the beaker will be filled. For sodium hydroxide, I choose 15 milliliters. I then click on the aqueous solution, nickel 2 chloride, located on the materials section of the shelf. I click and drag it to rest in front of beaker 2 and let it go. The same window opens, and I decide to fill beaker 2 with 6 milliliters of nickel 2 chloride solution. We can see that the color of the nickel 2 chloride is green, and the color of the sodium hydroxide is gray. The following step entails pouring the contents of one of the beakers into the other. In order to do this, we click and drag beaker 2, filled with nickel 2 chloride, in front of beaker 1, filled with sodium hydroxide. Then we let it go. Consequently, a window opens which serves to decide the volume of the solution of beaker 2 with which to fill beaker 1. I choose the Pour All option. As the contents of beaker 2 enters beaker 1, a reaction between the contents of both beakers takes place. We can see that the color of the solution is gray, and that a small green precipitate has formed at the bottom of beaker 1. In order to view the final solution clearly, I zoom into beaker 1 by clicking the plus sign located at the bottom right-hand corner of the screen until I can see the solution with the desired clarity. I can drag the screen until I can see the desired object. This observation translates to the fact that an aqueous solution of nickel 2 chloride has reacted with an aqueous solution of sodium hydroxide to produce a solid nickel hydroxide precipitate. The atoms remaining suggest that the other product of this reaction is an aqueous solution of sodium chloride. This is consistent with data from webqc.org, which is a chemistry website that balances chemical equations. The data suggests that the reaction should produce both a precipitate of nickel hydroxide and an aqueous solution of sodium chloride. This reaction of double displacement can be summarized by the following equation. To be more specific, we can see that 2 moles of aqueous sodium hydroxide react with 1 mole of aqueous nickel 2 chloride to produce 1 mole of solid nickel hydroxide and 2 moles of aqueous sodium chloride. Having completed the experiment, I must clear up the workspace. In order to do so, I drag each of the materials used to complete the reaction, beakers 1 and 2, on top of the organic waste bin, located at the middle bottom of the screen as shown. Once the workspace is clear, we are finished with the experiment. Thank you for watching.